We'll start again. Okay, so I want to talk some about the agent-based modeling platform process. Now, this may be a topic we revisit in more detail, considerably more detail later in this class. It's a topic which is textured and which affords a good several hours of discussion. But because of the uncertainties about some aspects of timing, and because I feel that a lot of the material, without being grounded by concrete examples, it'll be a little bit hard to operationalize in clear terms, I wanted to just emphasize a couple key points at this point, at this juncture, and then we may return to this as a more in-depth topic later. You'll certainly find lectures of me online where I go into this in more detail, but there's a couple key points that I want to highlight, bearing in mind that we may dive in further. So the first and most important point, a point to which I'll be returning many times, is the fact that while this process is typically conducted in the context of an interdisciplinary team and reflects an ongoing process of learning and refinement, it's also best placed in an iteration framework. I mean, ideally, you're working in a situation where you can be refining the model, giving recommendations for data collection or recommendations for intervention, design, actually having observations from the real world for those, and iterate accordingly. Traditionally, with an agent-based modeling, the agent-based modeling efforts, the greatest emphasis has traditionally been, in terms of the process, on insights gained from the model itself. Now, this is in contrast to a field like system dynamics, where much of the emphasis is, and I believe rightly so, on the modeling process itself as transformative. In system dynamics, there's a real emphasis on changing people's mental models and the fact that engaging in modeling itself, in modeling, not just with the model, can be really, really valuable for advancing the discussion, for advancing people's thinking about the system that they're in and advancing their sense of priorities. In agent-based modeling, just historically, I believe it's as much a sociological factor as anything else. The emphasis has traditionally been on the model as an artifact. This needn't be so. There's nothing that forces it to be so. I think it's a historical happenstance as much as anything structural. I will describe this process with the background of my firmly held belief that it's the modeling process rather than just the models created that offers the greatest value. Now, what does this process look like? This is to situate some of our discussions. When we come up to talk about calibration or about sensitivity analysis, or we talk about model conceptualization, we'll know where these fit in. I think about agent-based modeling as occurring in the context of a multi-stage sort of delivery cycle, which is highly iterative, hence the feedbacks back and forth, where a key deliverable is sort of how people think about the system, affected just as much, I believe, as in some system dynamics context, and where there's sort of a staging of sorts that goes on from a very qualitative understanding of a situation and problem conceptualization, where you're really setting the question of what's in the model. What's the boundary of the model, the scope of the model? What are the research questions? What are the patterns we wish to explore? What are the problems we're trying to solve? To a stage of mapping, where we're mapping out at a qualitative level what's in the model, to a stage of quantitative model formulation, where we're really getting down to brass tacks on the specifics of how one variable relates to another, to model sort of calibration and testing processes, which I've shown here separately, but the division is very arguable, which might involve cross-validation, where you're comparing the model against data not used to build it, and where you're testing the model with other sorts of tests, unit-based testing, extreme value tests. You're testing it, you're really pushing it and seeing how it behaves, and you're trying to get it to match historic data that wasn't fed into the model, but to which the model needs to remain true. And then going on to a policy evaluation phase and a knowledge translation phase. Now, what's particularly notable about this within an ABM context is we are often undertaking these steps itself within a high degree of iteration of sort of adding features to the model. And there's a very nice protocol that's undergone some advancement. So the ODD plus protocol, which outlines sort of features of specifying your model, describing your model for publication using pieces for each of these different phases. So, for example, the O stands for overview and D for design, the second D for details. And ODD specifies sort of features of describing your project that are related to things being set into place in each of these different phases. And I may come back and cover that more. The most important, arguably the most important thing that I want you to remember from a course about agent-based modeling, that's a strong statement. This may be the single biggest recommendation I have for any of you here. It's nothing about AnyLogic. It's nothing about areas where system science should be applied and should not be applied. It's nothing about performance or debugging your model. If there's a single thing, it's this one. It's what's on the screen here. It's about incremental model development. Case after case of models that have been built in the agent-based modeling area have fallen prey to what we call the Big Bang syndrome in software development. It's a case where you say, well, I'm going to build a model with these features, and it's going to be impressive. We're going to incorporate this endogenous factor, that endogenous factor. We're going to capture these characteristics of agents to be rich and all sorts of things. And you build towards that. And often that takes longer than you think. And often it's more tricky process, and it ends up taking a lot of time. And then you come out with something, and you run it, and you see really interesting things happening. But the question is, well, what do we do now? We see all these things happening, but first of all, are we even confident the model's working properly? After all, could these be bugs? They're interesting, but maybe they're interesting because it's flaky. Maybe there's problems with it, and they're interesting. And we don't know really what has influenced what. We have all these things in there. We don't really know what's contributing these patterns we see. It's interesting, but now we've got to unpack it. And it takes a long time to unpack it. That's if you're lucky. That's if the model comes together in time. Often the stakeholders are left waiting during that time. Engagement is diminished, and the situations are changed very different from when you started. So my foremost recommendation in this area is, if you're going to build an agent-based model, do so incrementally. Okay? This is par for the course in modern software development, where agile, incremental methods have been advocated for years for similar reasons. Traditionally, when we build software, there's a sense of building a big system that will deliver and a staged process for doing it, but it often takes longer and it's more buggy, and the stakeholders are not engaged with it, no longer so interested. When it's delivered, they get impatient while it's being delivered. And in modeling, it's particularly key, because it's not just a matter of building a model right, it's building the right model. And often, if you build it in a step-by-step fashion, you gain insights all through the process that will lead you to build a different model than if you had set off initially with a complete design for what you wanted to do. In other words, there's learning that goes on during the modeling process. You add things into the model step by step, you observe what's going on, and you learn from it. And it shapes your priorities. It shapes your sense of what's important, what should be left out, what you want to explore. So that's one big advantage. You learn, and it shapes you along a different course. So the model you get in a year's time or 2 years' time, that may be rich and big, have lots of good features in it and so on, it may be a very different model than if you had said, a year ago, what should I build? It's a model that's been informed by learning, by understanding. That's one feature. A second feature is, folks, agent-based models have lots of moving parts. They exhibit complexity. And if you build things up step by step, if something's wrong, if there's something that's patently unrealistic, or if there's a problem in the implementation, a defect in how you accomplished it, if you meant to do X and you actually told it to do Y, you'll discover it much faster. You'll discover it because it'll exhibit weird behavior immediately. You know exactly what you did that triggered that weird behavior. You go and investigate and you say, oh, I did something silly. I made this mistake. I undertook this. What I really meant to do was that. It lets you discover the problems much sooner. It also makes sure you have something in hand at any point. You have some model version that you don't have to wait for. Some model version that is not it's not, you know, two birds in the bush. It's a bird in the hand. You have at all points that you can bring to stakeholders. You can show them. You can keep them engaged. Moreover, when you're evolving the model, you can dock the new versions against the old version. So you add something in, and maybe you disable that thing initially, and you just make sure it reproduces what you saw earlier, and then you enable it, and you see what goes on. So that gives you, again, understanding of the benefits. So incremental model development within this broader context is highly advised. In other words, you go through successive enlargement of the scope of a model, successive enrichment of the model mapping and the model formulation, and all through the process you can check it with stakeholders, you can discuss the insights with colleagues, you can check it for bugs and more quickly find them, and you can gain insights all along the way about what's really driving certain patterns. Because you make one change and you see a new pattern emerge, and you know what was associated with that change. Okay? So there's a whole boatload of different benefits that come from this. Faster ability to understand bugs, greater understanding of where modern patterns emerge from, ability to learn from it and change direction accordingly, capacity to seek feedback from stakeholders, greater clarity and prioritization of pieces of model, more effective time boxing. If you only have so much time, you can do so with a model that's got a lot of assets in it already, enhance stakeholder confidence and improve morale. All these recommend incremental development. And I would suggest starting early and developing accordingly. Okay? So that's one big thing I want to talk about. I could talk about the ODD protocol, but it's a little bit dry at this point, and I think we should maybe revisit it later. Another thing, though, that I do want to emphasize is this. Early on in the modeling phase, a key goal is to delineate the model boundary, the model scope, what's in the model and what's not. And typically, this is a little bit easier to do within system dynamics, because in system dynamics, there's more of a, it's harder to implement certain things in the model, harder to capture certain things in the model. So there's a natural kind of force pulling you back from putting too much in the model. Within an agent-based context, the flexibility of the formulation is such that you can easily throw things in. And you got to be very careful in resisting the desire to throw lots in prematurely. It's very easy to add deep levels of detail, comparatively speaking, and therefore you can fall into the habit of sort of adding things in. So the basic principle I'd like to advocate here is the Yagni principle from software development. You ain't going to need it. So if you're not sure you're going to need it now, leave that to a later phase, add some things in you are more confident about, and fundamentally use the purpose of the model as a logical knife to cut away things that aren't definitely needed early on, and only add them as you have time and as your insight develops as to what's important. Okay? And there's an opportunity cost issue here. We invest in certain things, it takes our time away from other things. Now, a key step of this that I want to emphasize to you folks, I think many of you have done simulation modeling before, so I hope this is second nature to all of you, but it's a very important point for those from health background who are fairly new to simulation. We commonly get within the health modeling area people coming to us seeking to build modeling projects and focusing on the data side. They have this data, they have that data, they want to incorporate it, it has these characteristics. And that's all fine and good. It's all well. But what they're often less familiar with is the need to unpack their domain, not just in terms of the observables from which they have data, but in terms of the causal pathways involved. So You know, if we're thinking about the impact, say, of moving to opportunity type programs, housing voucher intervention programs, which move people from a low-income neighborhood on the one hand to a mixed-income neighborhood on the other, and we want to explain or otherwise anticipate their impacts on obesity, crime involvement, and graduation, for example. We may be dealing with outcomes that are measured in terms of obesity levels and risk of participation and criminal activity and high school graduation rates. But if we want to reason about the impact of interventions, we're going to be needing to think about the causal pathways that link up that intervention, say moving to a mixed-income neighborhood, with these outcome variables. And, you know, when people come to me in our modeling incubators, we run modeling boot camps and incubators, the latest one being last week, and they come with problems, one of the first tasks we sit down and talk with them about is unpacking these causal pathways. And that can be done in influence diagrams and causal loop diagrams and sort of sketching out the various linkages that apply between them. But so much of the time in modeling is spent understanding these causal pathways because it's important for understanding the trade-off between interventions. It's important for asking those what-if questions. If we did this, what would happen? If we did that, what would happen? We need to understand the differential ways in which they would affect different pathways to affect the outcome variables of interest. So much of the art of building up a simulation model is thinking about what are these latent variables we may not be able to measure directly, or on which we may not have data right now, some of which on which we may not have data, so that we can build a model that characterizes their impacts on the outcomes. And we routinely do this. It's a common feature of the modeling process that a lot of people don't recognize. And it's one that occurs during conceptualization phase and then is formulated more in the model mapping and formulation phase. Finally, I want to emphasize one aspect of model conceptualization that I think is really important, and this is drawn from the system dynamics area in terms of inspiration, but it's equally applicable and perhaps even more important in the agent-based modeling area. When you're thinking about a modeling project, try to delineate factors that you think are important into one of three areas, and do so consciously. Endogenous factors, these are simulated by the simulation model. We're actually having the simulation model generate them. It's producing them as part of its running. They're calculated by the dynamics of the model. Exogenous factors, they're represented in our model. The model represents them, but they're represented in a pre-specified way. And finally, things that are ignored. Things that we consciously put aside right now for this particular revision of the model because they're going to lie outside the boundary of this particular revision of the model. And often what happens over time through successive incremental divisions is you move things from here to here, ignored to exogenous or exogenous to endogenous, and it evolves. But by performing this explicitly, it helps you remember which things you put aside and reflect on them. Okay? This is, as I say, particularly important for agent-based models because it's so easy to add things in an endogenous fashion. It's so easy to add them in a way that, easy in the sense that you could throw them into the model without a lot of big overhead compared to in a system dynamics model, but often you want to do so in a careful fashion, and you want to do so by carefully reviewing what is your division of other items between these categories. Is this really the highest priority item that you're adding in? Okay, I've been talking at a fairly abstract level. I should note, just in terms of one particular example, say smoking, this is a choice where, you know, for a given model, a given model revision, we may have to divide, you know, up what's endogenous, what's exogenous, and what's ignored. For example, some models of smoking have hard-coded uptake rates. People, you know, tend to uptake at this age or that age or that age. And in fact, I've given you an example model where we have exactly that. It's sort of hard-coded factors. Another level of endogeneity would be to make those uptake rates not fixed, not dictated by age, but to make them depend on the prevalence of smoking in the group. And that might lend insight as to how an intervention that lowered prevalence in one group might ripple through to lower prevalences by indirect effects as well as the direct effects of the intervention. Fair enough. And it might explain fluctuations in the uptake rates we see historically. Another factor is we might have uptake rate depending on preferences involving peer pressure and factors having to do with the cost of cigarettes and the ease of their availability from chain stores, etc. So here we have a different level of endogeneity where we're capturing perhaps network effects, which might allow us to examine, among other things, interventions that use peer educators. It might allow us to target the peer educators of greatest interest. If we were to make this uptake rate dependent on those fashions, it might open up opportunities to additionally investigate interventions, but at the cost of added model complexity, of needing extra data to ground it, at the cost of extra time to develop it. So that's an example of a question of where do we draw the boundary? Do we draw the boundary such that peer pressure effects are endogenous, or are they exogenous? Are they being totally ignored? Another example would be mixing between individuals. To what degree are these hard-coded, for example, about how people mix together? To what degree is there a term that allows for risk perception? To what degree are they emergent from mobility? These are things that we have to decide in terms of the scope of the model. So I think I will leave this topic for now. I just wanted to orient you with respect to a few broad priorities here, particularly the issue of incremental development. I will note that there's a very rich literature associated with pattern-based modeling and pattern-oriented modeling in agent-based models, one that's been articulated no less than the pages of Science by Volker Grimm. And I would refer people to this for one articulation of a philosophy of modeling. Some of Josh Epstein's work on generative modeling is also worth looking at, okay? And Volker Grimm gives a strong impetus towards explaining patterns as the goal of the modeling, and has a strong perspective at sort of what that means in terms of boundary selection for the model. Okay, those are some very high-level comments on the modeling process before we dive into some hands-on work. Are there any questions related to what I've just presented? I know it's been very abstract, and hence why I'm not giving a full lecture on it right now. Any questions? Okay. Let's then dive into